Hey guys, we're going to do another video here on 8.3 if you're using the same book that we use in class. And today this video is going to be how can I find area or perimeter. So it's a little bit of a review video. Hopefully you've watched the ones previous to this. And what we're going to be kind of just summarizing is making sure you're really clear on the difference between area and perimeter. So for our notes today, we're going to do a couple different things. First, I'm going to write area versus perimeter. Area versus perimeter. And I'm going to make a T-chart out of this. So what do we know about area and perimeter? Well, they're both measurements. They're both ways of measuring some sort of shape. It's just they're measuring two different things. Area measures the space inside. So I'm going to write measures space inside. Measures space inside. And perimeter measures the space around the outside. It's the border, it's the perimeter, the edge of the shape. So measures the outside. I'm going to say the outside border. Kind of is an easy way to remember it. So they're both ways of measuring shapes, just one's the inside, one's the outside. And it's pretty important when you read a question not to get it mixed up in your head. Like sometimes people will read a question that says like find the area of this circle, but they'll accidentally find the perimeter. So it's really important to read and kind of think about what does area mean? What does perimeter mean? And for each shape, it's slightly different, to be totally honest. So over here on the main idea side, let's look at the most basic shape there is, like a rectangle. Rectangles are pretty easy to work with. So I'm going to draw a rectangle on both sides here that are going to be matching. And the rectangle is going to measure 1, 2, 3 squares down and 1, 2, 3, 4, 5, 6 squares across. So it'll look like this. And do the same thing over here. 1, 2, 3, 1, 2, 3, 4, 5, 6. So they're identical matching. I'll use my graph paper to make them matching. This is what we call a 3 by 6 rectangle. So it measures 3 units down and 6 across. 3 by 6, I'll label it 3 by 6. So if I wanted to measure the inside space, and I said, well, how big is the inside? What we do is we chop it into these little squares. Area is measured in these squares. It's how many little square units actually fit inside the shape. So if I was to go through here and highlight all of these graph squares, here I'll make this a little faster, it's just how many squares are there. Now your like first and second grade self, like elementary school, might sit here and just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But your like older brain self is like, well, there's a shortcut. 3 times 6 is 18. That's going to be way faster. And if we want to get real mathematical about that, we technically have a formula. Area equals length times width. Just multiply that 3 times that 6. So in this problem, our area is equal to, what do we say, 18 units. 3 times 6 is 18. And it's these little squares. So we say square units or units squared. They're the little squares. But if I told you let's measure the perimeter of this rectangle, okay, well perimeter is the outside edge. So it's like if I took my pen here and I started tracing around the edges, it's how long is that fence if I was to fence it in. So we're not going to do length times width. Instead, we're going to be like, well, it's 3, and then here's another 6, and then here's another 3, and then here's another 6. So if I add up all the sides, my perimeter is just every side added up. So my perimeter is equal to 2 of the lengths and 2 of the widths. 2 lengths plus 2 widths. And really, I don't even have to worry about the formula. I just kind of go around the outside edge and I'm like, okay, 3 plus the 6 plus the 3 plus the 6. And add that up. Let's see, 3 plus 6 is 9, so both of these would be 9. And 9 plus 9, oh how ironic, is 18. So we ended up getting the same answer as we did over here, but that's not going to happen very often. This was kind of a rare case. So our perimeter equals 18 units. Notice I'm not putting the little squared on there because we're not counting the squares. We're just counting how long on the border is this shape. So something a little bit different. Okay, so we've got perimeter, we've got area. Notice how they're different measurements. And this is kind of a rare case for them to match up like this. Maybe I should have picked a different example, but it can happen. Inside space, outside space. So we can do this with all sorts of shapes. Rectangles are kind of the basic, but we also do this with triangles, with circles, with pentagons, pretty much anything you can think of. That area will always be how many little squares fit inside, and the perimeter will always be the outside edge. The complication with some of that, I'm going to grab some more graph paper, is like other shapes don't measure out as nicely as a rectangle. I'll give you an example here. In fact, in your notes, let's just write example. Here's an example, a triangle. A triangle doesn't measure into perfect squares. So I'm going to draw a triangle that looks like this. And if I said, what's the area? Question mark. Well, to find the area is going to take a little bit of work because it means I want to know how many squares fit inside this shape. Well, that's going to be pretty tricky. In fact, I just freehand drawed it, so I don't even know if it's accurate. So instead of trying to count the squares, which really is going to be challenging, we use a formula. We say area of a triangle is base times height divided by 2. And if you've watched the prior videos, you know exactly where we get that formula from. So that shouldn't be new to you. So in this case, I'm going to give you some measurements now. I'm going to tell you that this is 5 inches long, this is 7 inches, and this is 6 inches. But if I said, okay, solve this problem now, you'd still be stuck because you don't know where the height is. Height is measured when you have a 90-degree angle. What we look for in the picture is we look for this little 90-degree symbol. It looks like this. It's a little box. It means 90 degrees. And that means you're straight up tall, 90 degrees, straight up. If you don't have that little symbol, you're really not going to know what the height of this triangle is. So let's find it. Let's say someone comes in and measures a line, kind of this imaginary line, going this direction. And they find out that it's 8 inches. 8 inches. Now we've got a height. What we do is we picture turning the triangle with our paper, and we kind of picture it like this. Base, height. There's that T. So it looks like 5 and 8 are the numbers I care about. I don't even care about the 6 and the 7 anymore. So if area is base times height, this time it's going to be 5 times 8 and then divided by 2. What is 5 times 8? Well, 5 times 8 is 40. So we have 40 divided by 2. And 40 divided by 2 is 20. So we get an area of 20. And what does that mean? That means if we measured all the little square inches, there are 20 squares inside our triangle. So we're going to write inches, but we're going to write inches squared because it's the little squares. And there's our answer. If I said, oh, wait a second, I didn't want area. I actually wanted the perimeter of this triangle. Then I would tackle this problem a little bit different. The perimeter is the outside edge. Again, it's like if I take my pen and I highlight the edges like this, that's going to be my perimeter. So in this case, the perimeter, P, is going to equal 7, 6, and 5. So we're going to add up 7 plus 6 plus 5, and I'll have my answer. So let's see, 7 plus 6, 6 and 6 make 12, so that must be 13 plus 5. And 13 plus 5 is 18. So the perimeter is 18. And we're going to say inches because we're measuring in inches around the triangle. Inches. And there's our answer. No square this time. We're not measuring squares. We're just measuring how long is the distance around the triangle. So what about circles? Because we have been working on circles too. Let's do a circle problem. Circles are kind of unique. They're one of the more challenging shapes. So example. And I'm just going to draw, for this example, like a random circle here. Boom, there it is. So go ahead and draw a circle in your notes too. And for a circle, if I want to find the area, it's pretty challenging to do to count squares inside of a circular shape because it's so rounded. These rounded edges make it tricky. So we've developed a formula. We've discovered one that works, and it's kind of unique. It's area equals pi r squared. And honestly, you kind of just, this is one of those things in life you kind of need to memorize. There's not a lot of formulas that you have to memorize, but this is a pretty nice one just to know. Area equals pi r squared. Pi r squared gives us our circle. So what I need to know is what's r. R stands for the radius. That means if I go to the middle of the circle and out to the edge and I measured it, I would have my r. So someone would have to tell me, or I would need like an actual ruler or some tools to do this. I'm going to tell you that our radius is equal to 3. So we have a 3-unit radius. So let's solve this problem. Area is going to equal pi, but now instead of radius squared, it's going to be 3 squared. And 3 squared means 3 times 3. So we're going to get 9. Area equals pi. Pi. Pi is about 3.14. Not exactly. Remember, it's that long decimal. It never ends. But we're going to round it. And we're going to times it by 9. And at this point, now that I'm rounding pi, I'm going to change my equal sign to a wiggly sign because we're getting a close, an almost exact answer, but not perfect. And I'm going to go to the calculator at this point. So let's see. We've got 3.14 times 9. Let's see, 9 times 3 is 27, so I'm expecting 28.26, something very close. So my answer is 28.26. And I don't know what we measured. Was it feet, inches, yards? So I guess I'll just say units squared since I don't have any measurements on there. Okay, well that's area. What if I wanted the perimeter of this circle? Okay, again, perimeter is the outside edge. It's if I took my pen and I traced all the way around the circle, how long is it? Because of that rounded shape, that's extremely challenging to do because it's not like you can take a ruler and go around the circle measuring it. So circles get kind of a special name for their perimeter. We call it the circumference. Circumference, but it's just another word for perimeter. Circumference means the distance around the circle. If I was to go all the way around the circle, how long is it? So again, a formula is so much easier than trying to measure it by hand. So here's the formula we like to use. Circumference equals pi times d. Pi times diameter. So our job is just to figure out what is the diameter. Now the diameter is if we were to go all the way across the circle the full length. So if the radius is 3, that'd be another 3. Our diameter is 6. Goes all the way across. So we're going to have circumference equals pi times 6. Or 3.14. Let's change pi. 3.14 times 6 is what our circumference is going to be. Actually, wiggly equal sign because we're starting around the pi. So again, calculator. We're just going to plug it in. So 3.14 times 6. What is that? Something close to 18, I bet. 18.84. Okay, 18.84. So our circumference, our perimeter is 18.84 units around the circle. If I knew it was feet or inches, I would write feet or inches if I had something, but I don't. So circles are kind of unique, mostly because of the rounded shape. It doesn't have straight edges. And so we've kind of renamed the perimeter as circumference, but it's the same thing. So to kind of wrap up this video, after doing a few of these problems, I just really want you to kind of go back to the front of your notes here. Make sure you feel really clear on the difference between what is area and what is perimeter, and the strategies to solving it. With straight edge objects like rectangles, you can just count and measure. But when it comes to like triangles or circles, triangles and circles, you got to get down into the formulas. With a triangle, you got to know that base times height divided by 2. With a circle, you definitely have some formulas to memorize, and they both involve pi. That's kind of a key number with circles. So that wraps up our video. Hope you guys kind of followed along with me, and I will see you in a future video. Bye.